Swayam Prabha. Digital India. Educated India.
Welcome to this lecture on transition metal organometallic chemistry from principles to applications. We have been discussing an important class of organometallic compounds, particularly the transition metal olefin complexes in the last few lectures. And what we had seen is that these transition metal olefin complexes are important as catalyst for many transformations. For example, hydrogenation, polymerization, oligomerization, cyclization reactions, and these are really important complexes, and it is important to know their reactivity as well as their bonding with respect to transition metal. With that perspective, we have also looked at the various preparative procedures available for transition metal olefin complexes, and we have looked at 2 or 3 methods in the past lecture. One involved the reaction of transition metal carbonyl halides with halide abstracting reagents in presence of olefin that led to the carbonyl transition metal olefin complex. We have also looked at the reactions with isomerization of olefinic back bond as a result of reaction with transition metal carbonyl compounds with elimination of carbon monoxide. We have also seen the method whereby under forcing conditions, thermal conditions, the transition metal carbonyl complexes eliminates COs, and in its void these olefinic ligands are bound. So, this dissociation of CO can be achieved under thermal conditions, thermal forcing conditions, as well as under photocatalytic conditions, where in presence of light the transition metal carbonyl complexes loses carbon monoxide and the void space is then occupied by the olefin. So, with that in the background, we are going to discuss some more of the examples that are available for synthesizing this transition metal olefin complexes in today's lecture. So, another important reaction is oxidative addition of coordinatively unsaturated complexes. So, for example, iridium chlorocarbonyl PPH3 plus alkene this is a 16 valence electron complex. So, this is both coordinatively as well as electronically unsaturated, and this can add against this olefin to give the product COCl PPH3 PH3. So, the oxidative addition of coordinatively unsaturated complex also gives rise to this metal olefin complex. and this, as a result of this addition of olefin, this has become an 18 valence electron compound. But one thing to note over here, that this olefin is still bound as an olefin, and it has not become a metallocyclopropane, and whereby sigma bonds are formed over here, and as a result the iridium center over here is still in +1 oxidation state. So, the complete oxidative addition has not really truly happened over here. To some extent, some back bonding from iridium to the olefin exists, but this moiety is predominantly olefinic in nature, being bound to iridium. So, this a coordinatively unsaturated complex has added on to an olefin to give this coordinatively saturated complex in this example. The other common method is the reaction of metal salt plus olefin plus reducing agent. For example, reaction of NiCl2 plus trialkyl aluminum in presence of this diene gives this trans cyclo dodeca triene nickel 0 complex, which is highly reactive, and the structure of this compound is this, where these 3 olefinic bond is coordinated to nickel, and this is sort of trimerization of this butadiene unit to give this cyclododecatriene and in presence of nickel. So, this can be seen as a template trimerization process, which was this compound was made long back in 1960 by Wilke, which when treated with olefin gives the first binary metal nickel olefin complex. So, this is the first binary metal ethylene complex, and stable up to 0 degree centigrade. And prepared way back in 1973. Now, reaction of this cyclododecatriene with C8H12 cord gives the nickel cord complex, and this is nickel cord, and this is a good source of nickel 0 precursor. So, what we see is that this metal salt with olefin and some reducing agent, over here nickel chloride is the metal salt, reducing agent is trialkyl aluminum, and olefin butadiene gives this cyclododecatriene coordinated to nickel, and then this is a highly reactive complex which can be replaced by cod as well as ethylene, 2 of the cod unit and 3 of the ethylene unit to give the very good nickel 0 binary olefin complexes. So, this is a very effective way of making transition metal olefin complexes, where you take a metal salt, an olefin and a reducing agent. Similarly, the tris ethylene platinum complex was made, in which the corresponding the platinum counterpart. So, it is taken by platinum dichloride 1,5 cod plus C8 H8 Li plus 1,5 cod in ether gives PT 1,5 cod 2 dimer, which when treated with C2H4 gives PT C2H4 whole thrice. This also is a reactive compound and stable under only C2H4 atmosphere. The same strategy can be extended for making the zirconium olefin complex. This strategy of metal salt plus olefin plus a reducing agent for example, zirconium tetrachloride plus sodium mercury plus C7H8 gives this C7H8 piece sandwich kind of complex. Zirconium, and this was prepared by Green in 1991. So, here this is the metal salt, this is the olefin, and this is the reducing agent. Here is another example reaction of rhodium trichloride plus C2H4 in ethanol, water, giving this dirhodium tetra olefin bis bridging chloride complex. Cl, 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 dirhodium, and the rhodium 3 over here is reduced by excess olefin. So, there is no additional reducing agent for this particular reaction, but the reducing agent comes from electron rich olefin itself. Is reduced by excess olefin. So, we are seeing that there is really a lot of methods which are available for preparing these transition metal olefinic complexes. They are quite diverse, and there are a lot of examples of them right, beginning with this thermal and photolytic cleavage of carbonyls from transition metal carbonyl compounds in presence of olefin to all these metal salts plus olefin plus reducing agent, ligand isomerization reactions and so on and so forth. So, what it sort of shows that there are a large number of methods available, synthetic tools available for preparing these transition metal olefin complexes. Here is another such new example, new methods of making it, which involves reductive cleavage of metallocene. Cobalt with potassium C2H4, potassium is the reducing agent in presence of olefin, and this replaces one of the metallocene as its potassium salt, gives potassium C5H5 at low temperature of minus 20 degree centigrades to give this Cp cobalt olefin complex, and this is used in transferring half sandwich. This particular reaction or this reagent is used in transferring half sandwich unit of CpCO. So, these being weak bounds, they can be replaced by other ligand, and this is how this unit can be seen as CpCO transfer or CpCO called half sandwich metal complex transfer unit. Similarly, butadiene transfer by magnesium butadiene complex by magnesium butadiene complex MnCl2 reacts with C4H6 Mg dot 2 THF plus PMe3 in presence of C4H6 THF at 0 degree centigrade gives minus MgCl2, giving this manganese 0 PMe3 Mn butadiene complex, which is a 17 valence electron complex. So, here the butadiene is transferred onto manganese from this magnesium butadiene complex. This is a very nice example where a manganese diolefin is prepared from magnesium butadiene complex, and the rest of the coordination sphere on manganese is sort of occupied by PMe3. So, the reaction is done in presence of PMe3. Another metal vapor synthesis MVP, and that is a new method that involves metal atom ligand vapor co-condensation. Or these are also called as metal vapor synthesis. Okay. So, in this this is a special technique requires special reacting vessels in which the metal is condensed with gaseous ligand or ligand solution of low vapor pressure on a cooled surface. And that will produce the organometallic compound directly. A very good example of this is given by molybdenum atom in the gaseous state plus 3 C4H6, that is also in the gaseous phase. This is co-condensation method, CC method, or also called MVS, metal vapor synthesis method. So, we are writing CC minus 196 degree centigrade. So, it is heated and then vaporized and then cooled and then brought to room temperature, gives this tris butadiene molybdenum complex where 3 butadiene units are coordinated to molybdenum, and this geometry around molybdenum is called trigonal prismatic coordination. And this is similar to a trigonal prism with molybdenum coordinated to olefin, and along the 3 edges of a trigonal prism, and hence this is trigonal prismatic coordination, and it is different from that of the regular octahedral coordination geometry. Metal vapor synthesis is a very useful method for preparing transition metal compounds. MVS or co-condensation method is useful for preparing organometallic compounds. Its limitations are low yields and require large amount of cooling agent, generally liquid nitrogen in many cases. So, here is another example, iron gas. That ligand also in gaseous phase CC or MVS produces this iron cod complex, which decomposes, is very unstable above minus 20 degree centigrade. So, with these let me conclude the points that have been discussed in today's lecture. Particularly, we started looking at various methods available for synthesizing these transition metal olefin complexes, and what we have discussed to begin with was this reaction of transition metal salts with olefin and presence of a reducing agent. That seemed like a very general method for producing these transition metal olefin complexes. We have also looked into reactions like metal vapor synthesis, like which requires special equipments to vaporize all the metal and then reacting with the vapor phase of the ligand, and then all of them co-condensing on a very cooled surface. This is a very useful method for synthesizing important organometallic low valent compounds, and we have seen two examples of that. However, the yields of these reactions are usually low and also requires large amount of cooling agents, which are sort of the limitations for this method. We have also seen the formation of transition metal olefin complexes by addition to coordinatively unsaturated compounds, as well as we have seen transition metal olefin complexes prepared from reductive cleavage of metallosyl compounds, and so on and so forth. So, with that we have discussed 7 or 8 methods of synthesis for various transition metal olefin complexes in this particular lecture, and we would also take this transition metal olefin complex in bit more details, look at their bonding and also their reactivity and property study in the subsequent lecture that is going to follow up on this. And with that, I thank you for being with me in this lecture, and I look forward to being with you in the next lecture. We are going to look up or take up these transition metal olefin complexes and their reactivity study and their bonding properties. Till then, goodbye and thank you.